all these type of threads. It's operationally infeasible to have a firewall for every VM. If you really want to protect, if you really want to segment, this is what you have to do.
Why can't you put a WAF for each application, and then how do you care for in your VMI? Let's say
See, some people like Illumio try to do that, but that has its own limitations. Anything that you are centrally monitoring has its own limitations. We'll talk about those things. But yes, that is one approach. That is a real approach. That micro-segmentation using firewall rules on each network interface of a VM is agent-based, and it is a heavyweight approach. Hypervisor-based approaches are much simpler to deploy. So now,
lucky I don't have that.
No more tuition.
No more rent for me.
So now, where are we taking from? We are executing this concept inside NSX. That is what is micro-segmentation. So how do we do that? So if you are doing a distributed firewall at the kernel level, and you're automating the moves and adds and changes that are happening at the VM level, you can technically create the scenario that is on the other side, on the second side. And that's what we are trying to do. For a given VM, the flow is physically like that, right? Now, you create a security policy, you apply it at the VM level. Now, the flow is governed by that security policy at the hypervisor. And when you move the VM to other side, that policy moves along with the VM.
Cool.
It's really cool, right?
No, I didn't get it. You said the policies move to hypervisor level, right? So
So you apply a policy at the hypervisor. If you do vMotion of the VM, the policy moves along with the VM.
No work.
No, but then what will this hypervisor have the
It
policy?
doesn't matter whichever VM it has, it will have that VM policy.
No, but I need some, I'm just giving that example of the WAF concept. Okay, so you put that firewall in the hypervisor. Now when you unplug this block and you plug it over here,
Your policies are per VM, per flow.
not by hypervisor level.
Yeah.
No, I'm understanding.
We'll talk about your WAF problem. So WAFs are actually, originally WAFs are only at the perimeter. Like Nextcaler, all of these guys, they don't do anything at the individual hypervisor level. There are only more sophisticated companies like Illumio that do the WAF type of work as an agent. But that's a old school concept. I mean, that's only valid in some verticals like financials and all. They're particular about that. It works for them. So now, physical firewalls versus virtual firewalls. What's the big difference?
That is 100,000, this is $10.
No, it's still costly. The price is not one of the differences. Actually, you will pay a little bit more in the initial deployments if it's 4 or 5 users. 4 or 5 ESX hosts. Once you go larger, so the big difference is, this is one approach is on the physical box. The other approach is you can actually define at the VM level. With the distributed firewall, you are defining at the VM level but executing at the hypervisor level. This is the difference. You get the picture, right? You define at the VM level, but where do you apply? You apply at the hypervisor level. That makes it easier, simpler, and better to manage. And performance-wise, doing that is very, very efficient. In fact, if you have more rules, it will still work fine. And the whole idea is now, because the firewall is distributed, the security is native to the environment. It is not a bolted on thing. And you can do a lot of automation with it. Now you can do segmentation, you can do this whole journey, you can go here very easily. Now you can do service insertions also, even more advanced level. You can put the application level NG and new generation firewall policies in conjunction with VMware flows. So you can insert services like Palo Alto into the VMware infrastructure. They work together. So how does it all flow? This way. So you can do advanced service insertion. Now you talk to the controller and you apply Again at the hypervisor level, policies are applied at all these layers. The traffic steering happens, same concept, goes to policy application of the Panorama, whatever application it does for the NGW. That's it. So it goes on. The path is much simpler. You don't go again every time you don't go out, do that hairpin. Now that application level policies is happening at the hypervisor layer itself. So you can see all of these are built into the hypervisor and they can stay anywhere on your data center. You have consistent policies. And if you move your VMs anywhere, you still have consistent policies across your data center.
Pluggable VMs.
Yes, sir.
So, for a change management approach,
Yeah.
how would you do reporting and approvals for those items at the at the host level?
Yeah, so the whole idea is around automation. You would create blueprints and you would deploy blueprints for the applications, and any change you're doing it the blueprint rather than redeploying policies.
And that's just user defined, or is there?
You have a nice UI where you can define the blueprints and change blueprints. We do that job for other companies.
So what is the difference on host firewall than the VM virtual firewall?
So that's what I'm saying, right? If you are doing a firewall at the perimeter, all of the rules and regulations are actually processed by that particular physical box. Or if it's a virtual firewall, that virtual machine.
I'm talking about in operating system, there is a concept called firewall. If you run a VMware,
Correct.
there is a machine, right? You have a Windows
Correct.
server.
That's what I'm telling you, right? I gave you three options. Remember this picture. Sorry. I told you that difference little before. This is the difference. Huh. That is the difference. So I was talking about Illumio and other guys. They use the host firewall capabilities, and they do policies over that host firewall capabilities. That still works, but then that requires a agent to master communication that's more heavier, more chattier, and little bit less consistent across your application. Whereas if you do a policy at the VM level and apply it at the hypervisor, it gets applied consistently even when the VM moves from one hypervisor to another hypervisor. Okay? Yeah. Well, I'm almost done. One slide, I think. So if there is any vulnerability, it can be quarantined very easily. So the whole idea is you can do very granular policies, you can do quarantine policies and apply them across your infrastructure very easily as a group, not just as individual VMs, because it's all software defined and programmable. Like that.
But if there's a 0 day and you don't react now because it's at a hypervisor.
See, you can't change physics. Physics of a 0 day is a 0 day. No matter where you are, it only makes you better because you can do it faster. Because now you can do it as a group rather than an individual VM and an individual case. So you can remediate.
Right?
Yeah, that's what I'm saying. The chances of mitigation are
Everybody is
now.
No, the issue is not that. The issue is if you want to do a remediation policy, the speed and agility with which you can apply a remediation policy is much very different from
But
how
the
you do
catastrophe is
other.
also very fast, right?
Huh?
The catastrophe is also very fast.
There is no difference in the catastrophe speed.
It take
Because
Doesn't
catastrophe
matter.
cannot use the existing.
So
use of-
first thing is we are doing our basic hygiene, right? Now you have policies that are already doing microsegmentation. So your attack surface becomes smaller by design. And then if it gets vulnerable, now if you want to apply, you can apply to a whole group. It's actually much simpler. And this whole idea is the performance. You can actually create huge capacity at very, very affordable cost. You can create like a 20 gigabits per second firewall capacity at almost at the cost of hypervisor plus licensing. That's
Because
it.
it's more efficient than the.
Yes, yes. East-west traffic, now you're doing it at the kernel. Now you don't have to have a really big box doing this packet processing. Because packet processing is happening in a distributed manner.
Now, doesn't that force then the hardware manufacturers to compete on a performance level or on a software features level?
No. In fact, what is happening is very different things are happening. Now, Intel is coming up with FPGAs built into Xeon, into the thing. Some of these functions of software.
CPU?
Yes.
Yeah.
Oh, wow.
So you can actually do encryption, lot of offloading can be possible with APIs and such capabilities.
So
In fact,
Intel is competing with Cisco now.
No, so actually now they're calling software in silica, right? So
that's what is the whole idea. So you can actually push some of these capabilities into silicon.
So databases are on the motherboard, so the moment you power on, it's up. But then, again, now this brings, where do you, it's going back to the core.
Yeah, going back. See, honestly,
So you have
in
different
fact,
concepts in motherboard.
if it a very interesting trend is happening, right now, NSX is being disaggregated from the hypervisor itself. So now there are NSX engines that are putting into Leota agent, like IoT agents. So it doesn't have to be virtualized to be managed by virtual firewall or virtual networking concepts. So you can have a physical IoT device with an NSX agent. In fact, mobile phones, the AirWatch client has got a NSX capability. You can do per app VPN all the way till the application. Yeah, you can do it today.
Per app VPN.
Per app, all the way till your content.
So each app has its own IP address.
It doesn't have to. The policies are going, all the translations are happening seamlessly. You don't know. Or the packet flow is happening securely all the way till the endpoint where the data is stored.
Do those applications say which one is doing this?
Yeah, you today if you implement AirWatch along with NSX in a given prescribed manner, you can actually create a per app VPN. Some companies, FedEx is actually using it today. Their app actually does per app VPN.
So you brought up IoT, right?
Yeah. I'm done.
Okay, let's quickly talk. You talked about per app VPN, right? So what tool you told about tablets?
AirWatch.
So we have used AirWatch. So what about the bandwidth? With all this, software defined, it is going to the silicon level. What about the limitation, speed, bandwidth? How it is improving?
It is a physics question. The issue is you're only adding few more headers.
Is it
That's
the
all.
load on the processor then instead of the
Yes.
Right.
Yes. You actually increase the load on CPU. You actually reduce the amount of VM density you can have. Little bit, not by a big margin, but single digit percentage.
So there's some overhead.
Yeah, there is.
But the
There's
CPU
no
cores are
free
going
lunch.
up higher and higher. And the cost is going lower, right, for CPUs?
Yeah.
Right. It's because everything's becoming more efficient.
Yeah.
So what is this NXX built with, at the software level? How do you have...
Oh, see, NSX is literally like it is like an IoT platform. It does MSNQ, queuing and all that. Between controller and the ESX host, it's actually doing messaging. It's doing messaging, all topics, push notifications. There's a whole lot of architecture stuff that I can go into. But it is a software application technically.
What language? Driver?
Originally, it was a combination of Python and C, and there is a lot of interesting stuff.
Is this now a direct competition for the
So the
OpenStack?
PhD thesis.
Well, this is nothing to do with OpenStack. And the OpenStack doesn't have anything equivalent to this.
But
In fact, the NSX-T is there, which actually runs on top of OpenStack. Now there is a version of NSX that is completely separate from VMware. Like there is a OpenStack version, I mean NSX version that runs across KVM, OpenStack on other. In fact, I don't know if it runs on Hyper-V, but at least KVM and OpenStack I know. They're launching it like this month or next month. There'll be like a public lot of storytelling will happen. So network virtualization is being disaggregated from server virtualization. That's the simple message.
So let me rephrase this. You know, when VMware came out, you know, the
That's
original computer architecture we had, you know, it could use only one CPU at a time.
Correct.
So VMware came and made it software based, and you could use that one CPU for you know many
Multiple machines. Yeah.
Multiple machines.
Abstraction and pooling. That's what it is all about.
So
Right?
now we are talking about NSX
That does the same thing for the network. That's
for
all.
the same thing.
It's very simple to understand. Yeah, that's it. So thank you very much. I hope this was useful.
yes,
Yeah.
resounding and connected.
Wow. Okay, doctor? Very good.
Thank you very much. Yeah.
Do you have a business card?
I will.
Same problem.
Very good.
So Ram, did you find me a solution?
I am thinking about it. I actually have a solution, but I am researching more. We are looking at something called